Let's say we have a limit equation given by limit x approaches infinity 1 over x. What is the y value? Like when when the limit x approaches infinity 1 over x, what's the y value? Now to figure this one out, what you can do is you can plug some numbers. Actually here we can directly substitute. If you divide 1 over infinity, that is 0, because you are dividing 1 by a large number, so that's going to be 0. Now to prove this one, you can take some random numbers like 1 over 10, and you see that gives us 0.1. And if you take 1 over 100, that gives you 0.01. And if you take 1 over 1000, that gives you 0.001. And you can see as the number in the denominator become larger and larger and larger, the y value approaching to 0. So here the function is approaching to 0. So the answer is 0. And that's it for this one. Now let's look at another one. Let's say if you have a limit x approaches negative infinity, what's that gonna be? Again, negative infinity and 1 over x, what's that gonna be? Again, that's 0, because you can plug in some number like negative 1 over 10, or you can say, since x is the negative values, we can put it like 1 over negative 10 is same as negative 1 over 10, and that gives us negative 0.1. And if you put 1 over negative 100, that's going to give you negative 0.01. And if you put 1 over negative 1000, that's going to give you negative 0.001. And you can see as the x value of the x value in the denominator become larger, I can say larger, when it's larger negative value, it approaches 0 as well, right? So in both way we are getting 0. When limit x approaches infinity, 1 over x is 0. That's it for this one. Now let's go ahead and see 1 over x graph. I'm going to remove this one and draw the graph right here. So let's remove this, and I draw the graph right here. Okay, the 1 over x graph look like this. This is 1 over x graph. Now from this one, let's say let's find out this one, where limit when x approaches 0 from the right side, what's the y value? In this, the given graph, here we have the horizontal asymptote, that is y is equal to 0, and also vertical asymptote, that is x is equal to 0. And when the x approaches 0 from the right side means from here to right to left. So from right to left, what's the y value? You can see this graph is like converging toward y value positive infinity. You can see going forever. So this is positive infinity right here. And what is the y value when limit x approaches 0 from the left side? 1 over x. If you look at this graph from left side means left to right. So you have to see where's the graph converging toward. You can see it going down and down and down. So that's going toward negative infinity. And that's some basic thing you have to know. Now let's look at some more problems. I'm going to go ahead and erase this one. Let's say we have a question like this. Limit x approaches infinity 1 over x square, evaluate this function. Now here 1 over x square, you can directly substitute, like if you put infinity in the denominator, that's automatically 0. But if you put infinity square, that's even larger than infinity, so therefore that's definitely 0. Now you can go ahead and prove this one by plugging some random numbers. Let's say if I'm plugging 100 square, that's 0.0001, and if you put 1000, that's going to be even more closer to 0 than this, right? So you can see as the value of x become bigger and bigger and bigger, the y value is reaching 0, is converging towards 0. So the answer here is 0. Now let's look at it. So from this one, like you saw, when we have 1 over x, we have 0. If we have 1 over x square, we have 0. Even if you put 1 over x cube, x power 4, x power 5, x power anything except x power 0, you're gonna get 0 and 0 and 0 and 0, right? So because that's a function, like from that we can derive a generic formula, like whenever we have a limit x approaches infinity, 1 over x power r mean any real number, can be is 0 a real number? Wait a minute, because if it's 0 the whole thing will be mess. Is 0 a real number? Okay, 0 is considered to be both real and imaginary number, so I would say except 0, if you put any value, this is going to become 0, because if you put 0, I think it's undefined, because infinity power 0 is undefined. Then after that we cannot do anything with that. So any value except 0, like if you plug it in for r, that's gonna become 0. Okay, so this is some generic thing we can know from this. Now let's look at another problem. I'm gonna go ahead and erase this one. Okay, let's try this one. Let's say we have a limit x approaches infinity. Eight plus 3x plus 4. Evaluate this function. Now here we have an x in the denominator. This automatically 0, because if you divide anything by a larger number, x means that a larger number, the function is automatically 0. So you can actually look at directly and say 0. But if you want to show steps, you have a question like this in university, you cannot, sometimes they may require some steps. So what we can do right here is we look at the higher power of x. Here we have x, right? So we can just divide, like we can just multiply by 1 over x, 1 over x, and expand this one. Like when we expand, this is going to be like limit x approaches infinity, 8 over x, and then 3x times 1 over x, that's 3, plus 4 times 1 over x, that's 4 over x. Now here if we substitute infinity for these x values, this is going to be 8 over infinity, that is 0. Then we have 3 right here, and then 4 over infinity, that's also 0. So we are getting 0 over 3, that is 0. So you can see this is what we are going to get. And the easier way is you can always look at, like if you have x and we don't have any x other than that, like we don't have any x in the numerator, it's automatically 0. Or if you have x in the numerator and x square in the denominator, that is still 0, because we can cancel one of the x, but still one x remaining in the denominator, that gives us 0. So you have to look at, if you have the higher power in the denominator. If you have the higher power in the denominator, the function is automatically 0 when x approaches infinity. And that's it for this video, guys. Thanks for watching. See you guys on my next video.